as we say, so on the web, as we have a number of these. As we say, so on the web, as we have a number of these are the three major formats we can use. The GIF, which as I say is 255 colors maximum, okay, but it's got these extra things that it can have transparency, and also inside the GIF you can have multiple images. Okay, in a JPEG it can have many more colors, 16 million, but it cannot have transparency. The reason why it cannot have transparency is because a JPEG is a mathematical model of an image. Okay, and whereas in a GIF you're saying this pixel, this pixel, this pixel. Okay, you say this pixel is transparent, this pixel is not transparent. In a JPEG you don't work on that principle. You don't say this pixel, this pixel, this pixel. What you have is a mathematical representation of the image, which therefore you don't go actually into pixel by pixel things, and that's why you can't have transparency on a JPEG. Okay, so let's think about color. Okay, the 16 million colors, which is what we have when we have true color. Each pixel is represented by an absolute RGB value. Okay, so for example 255 100 0, for example, that would give you a kind of red with slightly orange color. Okay, but the GIF uses 256 colors and uses a thing called pseudo color. Okay, where each pixel is not an RGB value. It is actually a pointer to a position in the palette. Okay, I'll just explain what that means. So for example, this is red, okay, and the value of red in some proper RGB terms is 25500. Okay, so that is what red is. The way, however, inside a GIF image, the way that works would be, you would say red is 3, because the red is the third color in the palette whose value is red. So therefore what we can do is, in every GIF we produce a thing called a palette. These are all the colors I am going to use. So that's color 1, color 2, color 3, color 4, color 5, color 6, color 7, whatever. And then when you actually produce a GIF image, you say pixel 1 is 3, pixel 2 is 4. Okay. And so therefore there are only maximum 255 colors. Okay, so that's the maximum number of colors you can have in the, sorry, that's I shouldn't have, that's pointless there. I shouldn't have put that there. But there are only 255 colors in the image, in the palette, and each color is just basically pointing to a different member of the palette. Okay, so that's how a GIF works. Okay, so if you like the GIF colors, for each pixel it has a code. Okay, that's how GIF works. Now, as I say, but as we kind of related to before, in order to reduce the image to 256 colors, it has to be quantized. Quantized is that process whereby you take continuous data and you put it into blocks. Okay, so if we have a picture of the sky, which is going to be continuous shades of blue to white, what we can have maybe is 6 shades of light blue. Light blue, lightish blue, not so light blue, bit dark blue, very dark blue, and navy blue. Okay, you can have, and then what you do is you find all the colors and you put them into the box, which is the nearest one, and that is a process called quantizing. Okay. However, usually the quality is so bad when you do that that you have to do something further, something called dithering. Okay, And by dithering, we mean approximating the colors in the original by combining things in various pixel patterns. Okay, so suppose suppose instead of 256, suppose you only had 16 colors. Okay, suppose you only had 16 colors. Okay, and you wanted to represent an orange. Okay, what would you put inside that orange? Because the 16 colors could only be the very basic colors of, like red, yellow. We suppose you're not allowed to use the color orange. How would you make an orange look like an orange?
Mixing 16 colors.
That's right. Well, you have to bind them together. So what you would put is something like red, yellow, red, yellow, red, yellow. And that process is called dithering. Okay, such that to try and get a certain color, you put 2 pixels of of related colors near it to produce the other color. So if you wanted to produce grey, you could put white and black, white, black, white, black. Okay. So that's the process. That's the process of quantizing. In order to produce a GIF, you have to do that, to dither and quantize. Okay. Now the beautiful thing about the GIF is that you can do certain pixels. You could say transparent, no color at all, nothing in it. Okay. So therefore, you can have transparency with a GIF image that you can't have with a JPEG, because the JPEG, as I say, being a mathematical model of an image, it doesn't allow transparency. Okay. However, have any of you ever come across the new format, the PNG? You see PNG? Okay. PNG is different because it has a thing called an alpha channel as well as the other colors. So it has red, green, and blue to represent all the colors, but it also has alpha, which means level of transparency. Okay, so you can have a level of 50% alpha. So it means that you'll get, so for example, if it was 25500, you'll get a red which is half transparent. So half of the color from underneath will come through. Okay, so these are the different values. So therefore, that's why the different models that each of these formats use, which they're basically using in order to reduce the amount of data, that determines what extra features these colors have. Okay. Now then we'll get in. Well, actually, so since it's about 12 o'clock now, we're halfway through. Should we just have a break now for about 5 minutes, and then we'll restart? Okay, brilliant. Thanks.
These slides are available on Telegram?
Yeah, well, they should be. I mean, the PowerPoint is. I'm just hoping that this thing is recorded correctly, and if it has, then you'll even hear my voice. Okay, right then. So you say you've already done a little bit about sort of compression techniques and things like that. Yeah. So have you covered LZW, the Limpel Zib Welsh?
This is sort of a dictionary-based approach, lossless.
Yes.
Which just substitutes the value.
Yes, that's right. I mean, typically that's what it does. It also covers things like putting sequences of colours become represented by shorthand. Exactly, it is a dictionary-based approach. So typically the most obvious and vulgar one is instead of saying red, 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 you say 5 red. And so therefore that is what is the GIF mode of compression. I mean, the actual reduction to 256 colours is not regarded as part of compression. That's regarded as just the limitation of GIF. That's not a compression technique, really. Okay. What is the compression technique inside GIF is the actual application of the LZW algorithm into this thing, which actually then reduces the file size. Now, it works on the principle of colours times occurrences. Okay, but there's a little bit. It's a little bit more complicated in regarding of color. Okay, the image is not stored as a continuous stream of LZW encoded data, but rather as an arbitrary number of sub-blocks from 1 to 255 bytes in length. So basically all it does, it takes these blocks, either 1 to 255 bytes of thing, and then just compresses those. Okay, it doesn't compress the image as an entire continuous stream. It's kind of these blocks. Okay, and also for the purpose of interlacing, GIFs are saved one row at a time. Okay, so it's quite slightly complicated. The interlacing principle. It's kind of of LZW as applied to a GIF. Okay, so really, if you think about it, it's going row at a time. So it's doing that, but it's probably not doing full rows. It's probably doing up to 255, 255, 255, whatever. And so gradually, that is how the GIF thing goes through these blocks of 255 on a horizontal basis, kind of row by row basis. Okay. The reason, why do you think we have interlacing? Why do we need to do it on a row by row? What's the purpose of that?
To load the image faster.
Yes, it is. It basically, because it reduces what is called perceptual download time. It means not so much that it shows the image faster, but the human being thinks they're getting the image faster. Okay, because instead of doing it, kind of waiting till you show it all at once, what with interlacing you can do is gradually show the whole image. Okay, gradually appear, but not vertically, not like this, not gradually going down. Okay, it's more complicated than that, actually. You actually do it by this method. First of all, you save every row and then every 8th row after that. Okay. Then you save row 4 and every 8th after row 4. Then you save row 2 and every 4th after row 2. And then you save every odd row. Let me just explain how that works. So if we imagine, here's the image. Oh, sorry, am I in the way? Oh no, you can see it. Perfect. There's the image. What you do is you save every 8th row. Okay, so imagine there's row 8, there's row 16, there's row 24, and there's row 32 at the bottom. So you save the first kind of like that. Then you save row 4, row 12, row 20, and row 28. Okay. So that means you've only done a quarter of all the things, but you've got virtually, you've got now a lot of the data of the image is already there. Then you do every 2 and every 4 after that. So you do that one, that. Okay, that means you've got virtually everything except every 2. So that means you've done half of the image now. You've done half of the image. You've downloaded half of the image. Okay, and then after you've done that, you do every row in between. Okay, then eventually you've got the whole image. But the beauty of that means that, suppose the image is, let's say 160K. To do every 8th row line, you only have to take 1/8 of the image. So you only need 20K, and you can show you get every 8th line. And what you can do is you can predict what's in between those 8 lines. Okay, and then you only have another 20K, and then you've got every 4 lines. So you've only a quarter of the image, and you can already see some detail. Then after 80K, you have the next 40K. That'll give you everything, every other line. And so that means that I can already begin to get an idea of the image after only 1/8 of it is downloaded. Okay, so that's why interlacing is used, okay, in GIFs. Okay, so now I'm going to give you a little question. What we've learned, okay, is that the way the LZW algorithm works is it finds patterns of colour or repeated occurrences of colour. It works horizontally, and it does it in blocks of 255 bytes. Okay, so it works horizontally. Okay, and it likes to find patterns of the same or very slightly varying colours as it goes across. Given that that is the principle, which do you think are the smallest? That is a colour. That is an image, by the way. That's a white square. Okay, there. Okay, but that's the only one. So looking at all these, well, let's try and put them in order. Well, you do it yourselves first. Let's do it. I'll give you 3 minutes. Try and work out yourselves which is the biggest image in terms of size, and which are the smallest. And we'll try to put them in order. Okay then. So have we got well, I think the smallest ones are reasonably clear. Which are the smallest ones? Which ones? Yeah, that's right. That's right. Number 1, that's the smallest. What's the second smallest? Oh yeah, sorry, you can't quite see exactly. What's the other really small one? We just want the repeats of the same block. The black one. Yes, that's good. That's good. That's number 2, definitely. Okay, so those are the 2 smallest. Now, it's much happier if there are changes. If there are changes in the vertical, not some. It's happier if it's all the same along the horizontal. It's very happy. If there are changes along the vertical, it's not so happy. So, which would you think is the next one? That's right. That's right. The red and white one here. That's number 3. There's only one change in the vertical there. That's right. Okay. So then, what comes the next after that? Which one? Possibly. I'm not sure about that one. I think it's this one. But maybe it's the vertical web one. I'm not sure. So it could be. It's either that one or that one. Because once you get into the middle, it's much harder to actually work out the differences. Okay. Well, that's the top ones. What about which is the biggest of all of these by a long way? Which is the biggest file? The 13, 10. Yes, it is definitely that one. That is definitely I think there are kind of how many pictures are there here? There's 6. I think there are 20 altogether. So that is definitely number 20 there. Okay. Now then, which is the second biggest? Which is the second biggest? Remember, it's one which has the most changes in the horizontal, which will be the biggest. That's right, exactly. That one would definitely be number 19. And there's one other one which has quite a lot of changes going on in the horizontal. Yeah, don't think it's quite as much. I think it's this one here, because here you've got certain of the ones where it's changing a lot between them. So I think it's this one. I think it's that one is number 18. Okay. Now then, the other ones are kind of like, so basically it is the same principle. I mean, I'm not sure. I mean, I'll email you a web page which has got the exact answers and it's got the exact sizes of the files. But as far as I imagine, it's probably. Unfortunately, I've got this up to. These are what I've written down anyway. For The other, well, the easy ones are going to be, for example, this one here. That's another nice one because it's kind of mainly horizontal. Okay, this one is that's not too difficult because that is vertical, but it's only one vertical change. Okay, that one has got quite a lot of horizontals going on, so that's maybe taking a bit. That's mainly horizontal, but it's got quite a lot of changes as it goes down. Okay. That one is still mainly horizontal, so it's not too bad. Where did I put 10? Now then you get into the ones. Well, it's the vertical ones here. Probably, I'm not sure, but maybe this one here, or I don't know. No, I think this one might be less than this one. Okay, and then you're getting things like this one, this one, this one, and then. That is, I think, what I would put the numbers at. I'm sorry, I'm not exactly sure, but as you see, that is why it's quite variable, the actual size of GIF files. Okay, if you ever wanted to know how to reduce a GIF file, the best thing is to actually reduce the kind of the number of different speckles of color. That is one of the quickest ways. I mean, we'll do Photoshop this afternoon. I can show you how you can do that sort of thing. Okay, but that is why a GIF is quite variable in terms of the actual size. Even though the number of pixels could be the same, the actual size of the file that will produce. That is, all of these images. I mean, most of them are just about 1K. It's this one which is about 5K, and this one which is about 2.7K. Most of them actually don't get above 2K. But this one goes up to 5 because it's so much more difficult to compress, this one. So that's why they vary so much. Okay, but anyway, let's move on to the next.